Alright, good morning. We're going to go over 2.3, which is information from graphs. Now, the completed notes have a few more slides than this one just because I added more examples, but we're going to run through these as we usually would. So, in order to find values from a graph, again, function graph would be a graph that doesn't overlap the x values. You're going to find the x point and then you're going to find the y point for that graph. So, what does this mean? The function t graph in figure 1 gives the temperatures between noon and 6 p.m. at certain weather stations. So this would be considered noon, just because it's telling us it's from noon to 6. So this would be 1 p.m., 2 p.m., 3 p.m., and so on. But if they ask you what's the temperature at 1 p.m., then you will go at where 1 p.m. is, so right here. And then look at where the y is for the graph. So we go up, and right here they cross at 25. So at 1 p.m. is at 25 degrees Fahrenheit. If they're asking you for 5 p.m., then you look at where 5 p.m. is on the graph, go up where that line is, and we hit that point. That point is 20. So it's going to be 20 degrees Fahrenheit. So you would do that based on the information they're giving you in order to find it. Again, they could ask you what's at 0, but 0 means noon, so you can say what's at noon. We will look right here. That is 15. So they could ask you for every single x value, or in this case, the temperature of the function, or they could just ask you for 2 or 3. It depends on, again, the type of question. Now, using the graph from the previous slide, we're going to answer all of these questions. So we're going to look for T1, T3, and T5. So for A, we have T1, T3, and T5. Now if you guys look at the graph, T1 is at 25, T3 is at 30, and T5 is at 20. We found 2 out of those 3 in the first slide. Now let's look at B. They're asking which is larger, T2 or T4. Well, let's figure out what T2 or T4 is. T2 is approximately 35. It's a little bit under. And then T4 is 25. So 35 is bigger than 25. And again, if you also see the curve of this graph, T2 is higher, in a higher position than T4. So we can say that T2 is greater than T4. Let's figure out what C is asking. They want us to find the value of which x, or values where x is equal to 25. So we're going to be looking for the T of x when the temperature is 25. So we're going to look at that graph and we're going to figure out where is T of x 25. We have actually 2 places. We have T1 and we have T5. The graph goes up and down, so that's going to be the 2 places where T is 25. Now let's look at D. They want us to find the value of x in which T is greater than 25. So again, they're telling you the y value greater than or equal to 25. So we're going to start with T1 because we know that's already 25. We're going to see, well, T2 is higher, so it's bigger. T3 is bigger. T4 is bigger. Actually, T4 is 25. That means I counted wrong on the other one. This is T4 for C as well, not T5. Made a mistake when I wrote it down. I counted it wrong. And then for E, they want us to find the net change in temperature from 1 to 3 p.m. So the way you find this is you're going to find the points. So let's find the points of 3 p.m. So the points of 3 p.m. are 3,30. And then the points for 1 p.m. are 1,25. And then to find the net change, we're just going to do the same slope formula. So y2 minus y1 over x2 minus x1. So it's going to be 30 minus 25 over 3 minus 1. That's going to give us 5 over 2. So you can leave it as 5 over 2 degrees, or you can change it into 2.5 degrees. It's really up to you. But the answer is the rate of change. So you can leave it as a fraction or as a mixed number. So let me highlight all of the different answers that we have for A, for B, for C, for D and E. So I highlighted all of the answers. Now they want us to find the values of the function, the domain, and the range. Remember, the domain is always the x, and the range is always based on the y. So the graph of a function helps us to picture the domain and range of the function on the x-axis and y-axis as shown in the box below. So how do you find the domain and range from a graph? Again, the domain would be the x values and the range would be the y values. Let's read what it's stating. The domain and range of a function y equals f of x can be obtained from the graph of f as shown in the figure. The domain is a set of all x values for which f is defined, and the range is all the corresponding y values. So the domain would be from where the points start to where the point ends. So the x values here. And then the range would be, again, the same idea, when the points start to where the point ends for the y value. Now, when you're writing these down, you write them down from least to greatest. So if we had, I just put 2 points down of the domain 2 and 6, you would write the domain to be, since they're both closed circle, 2, 6. You can also write it, I know you know about it a few different ways. It's another way that domain could be written. Depends on the type of domain you're being asked to write. You can either write it in interval notation, which is this one, or you can write it in inequality version, which is the second. I personally prefer interval notation, and I think that's what it asks on the test, either way. So just keep interval notation in mind. You're always going to go from least to greatest. I'm going to do the same thing for the range so you guys see it. I'm going to write, 3 and 7. I'm making up these numbers. So for the range, you would also start from the lowest point, in this case being 3, the highest being 7. So it's not necessarily where the point ends, it's from the furthest down to the furthest up. Same for the domain, furthest left to the furthest right. So for the least to the greatest point. So let's look at increasing and decreasing functions. The easiest way for me to be able to get you guys to understand this, please, if this doesn't make sense, or if it makes sense, let me know. You guys may or may not have seen this in Algebra 1, which is a different type of slope. So increasing and decreasing functions are based on slope. So if we go from left to right, kind of like this drawing I just did, that's a hiker going up a mountain through a flat point, to a flat part, down a mountain, and then he falls off the cliff. Now this is all referring to slope. Going up the mountain again from left to right is a positive slope, which that means is an increase in the slope. A flat part is considered a constant slope because it's 0, it doesn't change. Then we have the going down the slope, which that would be a negative slope, which is considered the decreasing portion. And well, when he falls off the cliff, he can no longer hike. That is an undefined slope, which is the vertical line. I just drew the whole thing. For this part, you're just going to need probably the first 3. So let's read what is stated here. It is very useful to know where the graph of a function rises and where it falls. So I guess increasing and decreasing. The graph shown in figure 5 rises, falls, and rises again as we move from left to right. Again, just like a book, is the easiest way for me to remember this. And it rises from A to B, it falls from B to C, and it rises again from C to D. So again, the graph gets broken up into different sections. The increasing section, the decreasing section. In this case, we don't have a constant section. But if not, it would be broken up into that. So the first part would be broken up from A to B. So right where that curve changes from increasing to decreasing, this would be a positive slope. As we go left to right, they will be increasing. So the hiker goes up the mountain. Then it gets broken down again at point C, because that's where the curve goes from down back up to up. This is going down the mountain, so that's considered decreasing. And then we finish in the last section, which is from C to D, which is again where it changes from down to up, meaning the hiker goes up the mountain, so it's increasing. So you would say F is increasing on A to B and C to D, and then F is decreasing from B to C. So it broke up the sentence at the bottom, A to B, which is this part, C to D, which is this part, and then it's telling us that it's decreasing from B to D, and B to D is that middle part that I did in green. So increasing and decreasing functions. The function F is said to be increasing when its graph rises and decreases when its graph falls. So again, positive slope and negative slope, or guy going up a mountain, down a mountain, whatever makes it easier to remember. So the definition of an increasing and decreasing function is, if F is increased on an interval I, if f of x of 1 is less than f of x of 2, whether x1 is less than x of 2, then I. What does that mean? If your first point right here, this is x1, is lower than your x2, then it's most likely increasing. Well, it's not most likely, it is increasing, because you're going from a down point and then you're moving up with the graph. So if this point is, I don't know, 1, 2, this point would be, I don't know, 4, 6. I'm just making up points. But again, x1 is less than x2, and so it's increasing as the whole thing moved up. Again, this is based on always the x value. The y helps determine it, but the x value is the most important, it's the independent variable. So f is decreasing on the interval if f of x of 1 is greater than f of x of 2, whether x of 1 is less than, whenever x of 1 is less than x of 2. So what does that mean? This is your x1, this is your x2. I'm going to choose the same points just for consistency purposes. Notice how x1 is now, wow, hold on. I wrote that poorly. It should have been 1, 6 and 4, 2. Technically, the x of 1 is still smaller, but as we move down, we can see the y value is decreasing. So we're able to tell that this function is decreasing by looking at the different order pairs. So now we have example 6, finding intervals on which a function increases and decreases. They also want us to find the domain and range of f, and to find the intervals on which f is increasing and on which f is decreasing. So they're asking for the domain first. Let's figure it out. For the domain, I am going to find the most left point, which in this case is this one, and the most right point, which in this case is this one. What does that mean? I'm going to start from the left. When I count, it's 1, 2, 3, 4, 5, 6, 7, 8 to the left. So I'm going to put a bracket, -8. Now, why is the bracket important? This is a closed circle. As we move to the right, the furthest right point is 1, 2, 3, 4, 5, 6, 7, 8 as well. But because it's an open circle, we will put a parenthesis as it's not included. So remember, closed circle is bracket, open circle is parentheses. This is a reminder. This has to do with the type of inequality, what's included and what's excluded. But for now, and don't forget, infinities, whether positive or negative, are always going to be parentheses. Now let's look at the range. We're going to find the furthest down point, which is this one, and the highest point, which is this one. So after we figure that out, let's count to see where we start and when we finish. It's going to be 1, 2, 3, 4, 5, -6. And then the highest point is 1, 2, 3, 4, 5. With a bracket on both sides, as the 5 is included and the -6 is included. Yes, I know we have that open circle right here, but since we have another value of y right here, and right here, and right here, which is exactly the same as that open circle, we can include it as we have multiple answers that could be a solution for that y. Now, let's figure out increasing and decreasing. So let's figure out where this graph changes directions. Changes directions right here, changes directions right there, it changes direction right there. So we're going to have 4 different sections. Now for increasing, again, going left to right, we're going to do it based on the x value, always. So for the increasing, let's start. We're going to go up this way, so it's going to be -8 up to -4. These are going to be in parentheses. And then the other increasing section is going to be this part right here. So it's going to start at -1. And it's going to end at 1, 2, 3, 4. Again, in parentheses. Now let's look for the decreasing. It's going to decrease right here. So it's going to start at -4. And it's going to stop at -1. And then the other decreasing is going to be this way right here. It's going to be from 4 to 8. Again, in parentheses, because these are just the segments of the graph. The domain and range, the brackets do matter. But for the increase and decreasing, just keep it with a parentheses. Now, what is the constant? There is no constant. Remember, a constant would be a line that is just horizontal on that graph. We don't have that for this problem. So in this case, there is no constant. So if you guys get on your test a question that has no flat lines on the graph, write no constant, okay? Or none, or there's no constants, or anything that will let me know that's not a constant. Please do not write 0, because 0 is a number. And it is, I accepted it for the equation ones, but I can't do that for the graphs. So please make sure you write none or not a constant when it comes to if you don't have one. If you have one, you would write that little segment, whatever it is, the same way we would do increase and decrease, just for that horizontal line. Okay, so find the domain and range and use interval notation for increasing, decreasing, and constant. So for the domain, we're going to look at that x value from the farthest left to the farthest right. The farthest right is an arrow, so that's going to be an infinity. So we're going to start at 1, 2, 3, 4, 5, 6, 7, 8. So -8, comma, positive infinity. Again, from left to right. For the range, the highest point is this one right here again, for the y value. But we don't have a minimum point because we have an arrow. So we're going to start with negative infinity. Again, from the most negative to the most positive. So that's going to be 1, 2, 3, 4, 5. Again, in a parentheses, just because the highest point is an open circle. So we can break the graph up into this segment right here, this segment right here, and then the remainder segment. So for the increasing, we only have 1, which is this one. So it's going to be from -2 to 1. We have decreasing, which is this one right here. So we're going to have from -8 up to -2. And we have the other decreasing segment right here, which is going to be 4 to infinity. And then we have a constant. This will be this flat section right here. So it's going to be from 1 to 4. And then they're asking us to find f of -6 and f of 5. So let's look at where f of -6 is. We're going to be 1, 2, 3, 4, 5, 6 right here. We look at that y, which is 2 points higher. So it's going to be 2. And then f of 5 is 1, 2, 3, 4, 5. We go up. It happens to be 2 again, so your solution is 2 for f of 5, f of negative 6. Now, for the next one, we gotta find our domain, our range, increasing, decreasing, and our constant. And then f of negative 9, 0, and 4. So, our domain, our farthest left point, this is a piecewise function. It breaks up into different ones. So, it's gonna be from here up to here for the first domain. So, it's gonna be 1, 2, 3, 4, 8, 9, negative 10. Up to 5 with a bracket, and then we're going to hop for the union, negative 3, up to 1, 2, 3, 4, 5, and then union, bracket, 7 to infinity, because it keeps going with an arrow. Now for the range, again, we're going to do it from the furthest down point to the highest point. The furthest down is going to be this one. So that's going to be 1, 2, 3, 4, negative 4. As I go up through this, yes, I have a gap here, but it gets covered over here. So I can keep going. This open circle gets covered over here. And it just keeps going up to this point right here. So everything else, anything that could be an open circle gets covered up to the last point right there. So that's going to be up here. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 with a parentheses, and that would be a range. If there was a gap that no closed circle or no line would cover, then we would do the union and separate it just like we do with the domain. But in this case, all of those open spaces or all of those open circles gets covered by a different line. Now let's figure out the increasing and decreasing. We have different sections. We have first section of the graph, second section of the graph, third section of the graph, and then the fourth section of the graph. Now the first section is this one that's actually decreasing. So I'm going to go ahead and I can just go ahead and write it. That's going to be from negative 10 to 5. Then we have another decreasing section, which is section 2 right here. That's going to be from negative 3 to 0. I have an increasing section from the other side, so that's going to be 0 to 5. And then I have on the last segment right here a constant, so that's going to be from 7 to infinity because it stays flat for the rest of the graph. Now let's figure out what f of negative 9 is. We go to the x value, negative 9 is right here. We go up 1, 2, 3, 4, 5, 6, 7, just positive 7. They're looking for f of 0, so our x value is 0. So 1, 2, 3, 4 down, so negative 4. And we look at f of 4, 1, 2, 3, 4 right here. Go 1, 2, up. If they would have asked by chance for f of, let's say f of 5, and we look at where f of 5 is right here. We go to the closest line. It's an open circle. Because it's right on the open circle and you don't have any other options, this we consider a no solution. So please keep that in mind. I know it's not asked, but just keep that in mind when it comes to this. Now this is a completed example of how finding the domain and range from the graph. Another way you can do it is using the XY table, which we did on 2.2. I just showed you here how it's done, plugging in random points. After you plug in random points, I get two that are no solutions, so I know it's just going to be from that section to that section. Also, square root can't be negative when it comes to being an even one, so that's why it's only on the positive. The domain and the range. I'm not going to go too far into detail for this problem. I want to focus on the other stuff. So, this is what I mean that was missing, which is the local maximum and minimum values of a function. So finding the largest and smallest value of the function is important in many applications. So for example, if a function represents revenue or profit, then we are interested in its maximum value for the function, and that represents cost. and we would want to find its minimum value. We can easily find these values from a graph of a function. We first define what we mean by local minimum and local maximum. What does that mean? If you have a graph and it just, to say it does that, your local maximum is going to be the highest point of that graph that you can graph. So in this case, it would be this. And the local minimum would be this, because it's that furthest down point. Now, if you have a graph that looks like this, let's say it looks like this, and it keeps going with an arrow, this will be your local max. Because again, it's what you can graph. It doesn't keep going on forever. And this will be your local minimum. We're going to go over better drawn examples. This is just an idea so you guys can get your head wrapped around it a little bit. When it comes to the graphs with an arrow, then it will be what you can graph. If it doesn't keep going on forever, then you will find the highest and lowest points, and that will be your local maximum and your local minimum as well. So, local maximum and local minima of a function. The function value f of a is the local maximum value of f if f of a is greater than f of x when x is near a. So, you can have more than one local maximum point. It just depends on the interval that you're using. So what does this mean? This means that f of a is greater than f of b for all x in some open interval containing a. In this case, we say that f has a local maximum at x is equal to a, and it also applies for local minimum. So the function value f of a is the local minimum value of f if f of a is less than f of x when x is near a. So this means that f of a is less than f of b for all x in some open interval containing a. In this case, we say that f has local minimum at x is equal to a. Again, so kind of what we went over before. Your local minimums are the local lowest points of that graph, and the local maximums are the highest points of that graph. You can have more than one, again, depending on the interval. Sometimes it'll be 1, sometimes it'll be 2, sometimes it'll be 3. In this case, we have 4, 2 maximums, and 2 minimums. Local maximum and minimum values of a function. So we can find the local maximum and minimum values of a function using a graphing calculator. If there is a viewing rectangle such that the point A of f of a is the highest point on the graph of f within the viewing rectangle, not on the edge, then the number f of a is a local maximum value of f. So again, this is showing you the local maximum and the local minimum based on the highest point of that curve and the lowest point of that curve. This curve technically keeps going on forever. The arrow just didn't show up when we brought this into PowerPoint. So, example A, finding local maximum and local minimum from a graph. So finding the local maximum and minimum value of f of x. So we have this function x cubed minus 8x plus 1 rounded to 3 decimal places. The graph of f is shown in figure 10. So these keep going on forever. It's just not shown. Obviously, we don't have an ending point. So we're going to look at the maximum. Again, it's all for you because it's the completed notes. Would be that highest point. So it's going to be -2. And then the y value is 10. It's going by tens. So this is 10 and this is -10. And then the minimum is going to be the lowest point, which is 2, -10. And again, you would write it as an order pair because it's the point on the graph. So this is graphing piecewise functions. We did this last class, 2.2, I think it was. Again, we just do an XY chart, plug in this XY charts based on the domain. X is less than -2. It's between -2 and 2, and it's greater than 2. For the first one, and then for the second, we do the same for x is less than 0, and then for x is greater than 0. You just plug in some points and graph them based on the domain. Always plug in the domain points, so the 2, the -2 for the top, and then plug in 0 for the bottom. Some will be open circle, some will be closed circle.